Hello and welcome. Today we'll be solving example number 5 on Carnot cycle. So the question says, in a Carnot cycle, the maximum pressure and temperature are limited to 18 bar and 410 degrees Celsius. Alright, let's stop there. Now, the first thing we are going to do is to draw the PV and the TS diagram of a Carnot cycle. And this is the PV diagram. This is our what? TS diagram. All right, now from our PV diagram and our TS diagram, we have state 1 to 2, 2 to 3, 3 to 4. State 1 to 2 is nothing but our what? Is nothing but our adiabatic or isentropic compression process. Our state 2 to 3 is nothing but what? Isothermal heat addition process. Our 3 to 4 is nothing but what? It's nothing but adiabatic or isentropic expansion process. And state 4 to 1 is nothing but what? Isothermal heat rejection process. Please take note of that. All right, so now we are told that the maximum pressure. What is the maximum pressure? P2, P1, P3, P2, right? Our P2 is our maximum pressure. All right, so now P2 is given to us to be what? 18 bar. P2 is equals to 18 bar. All right, now, and we are told that the maximum temperature too is what? 410. But if you come to our TS diagram, you will observe that T2 is equals to what? T3. So the maximum temperature here is nothing but what? T2 and what? T3. You can see that T2 is equals to T3. So you can say that T2 is either you say T2 or you can just say T2 is equals to T3. Everything equals to 410 degrees Celsius. But we are going to convert this to what? Kelvin, by adding 273. So if you do this now, you are going to have 683 Kelvin. All right. Now, the next thing is they said the ratio of isentropic compression. Where do we have our isentropic compression? We have it at what? State 1 to 2. So our isentropic compression ratio is nothing but what? V1 all over what? V2. So we are going to have V1 all over V2 to be equals to what? To be equals to 6. And again, the next thing there, they said an isothermal expansion. Please, we have isothermal expansion is what? 1.5. All right. Now, you need to know something here, that this isothermal expansion is a trap. You can mistakenly think your isothermal expansion is process 3 and 4. No, that is not correct. Where we have isothermal processes is state 2 and 3 and state 1 and what? And 4. Our isothermal process is nothing but what? 2 and what? Sorry, our isothermal expansion is nothing but what? Between state 2 and 3. Please take note of that. We don't have any isothermal expansion yet. Once they mention the name isothermal, you should know it is either state 2 and 3 and state 1 and 4. So when they say isothermal expansion, it is state 2 and 3. So you can also say isothermal expansion is also the same as your what? As your isothermal heat addition process. Please take note of that. And this isothermal expansion ratio is nothing but what? V3 over what? Over V2. All right. V3 all over V2 is equals to what? 1.5. All right. Now, they said, assuming the volume of air at the beginning of isothermal expansion. The beginning of isothermal expansion. This is our isothermal expansion, right? This is our isothermal expansion. It's nothing but what? It's nothing but 0.18. So the beginning is what? V2. So we are going to have V2 to be equal to 0.18 meter cube. All right. So now, let's start with the analysis now. We are told to find the temperature and pressure at all silent points. So that is, we want to find T1 and T2 and T3 and T4. T1 and T2, we have already been given T2 and T3 from the question. So we need to find T1 and T4. All right. And we are going to find pressure P1, P2, P3, and P4 at all silent points. So let's start. We are going to start with process 1 to 2. So from process 1 to 2, you are going to recall the relation between temperature and volume. T2 all over T1 is equals to V1 all over V2 all to the power of gamma minus 1. But you are going to recall carefully that V1 all over V2 is nothing but what? It's nothing but 6. So let's substitute all these parameters here. T2 is already given to us to be 683 all over what? T1 will be equals to 6 to the power of 1.4 minus 1. Please take note that our gamma is gamma is equals to 1.4. All right. So now we want to make T1 the subject. We want to find our T1. So for us to get T1, we are going to make T1 the subject. So T1 will be equals to 683 all over what? All over 6 to the power of 0.4. 6 to the power of 0.4, which will be equals to, so if you press this value in your calculator, divide this by this, you are going to get what? 333.55 Kelvin. 333.55 Kelvin. All right, so that is our T1. All right, so still at process 1 to 2, we are going to relate our temperature with our what? Our volume. So T2 all over T1 will be equals to what? Will be equals to V2. Sorry, we are going to replace it with our pressure, pressure, please. So P2 all over P1 all to the power of gamma minus 1 all over what? Gamma, right? Now, let's substitute all the parameters that we have here. We already have our T2. Our T2 is what? 683 all over our T1. Our T1 is 333.55. So this will be equals to P2. What is our P2? Our P2 is given to us as what? As 18 bar. So that is 18. 18 all over what? P1 all to the power of gamma. Our gamma is 1.4 minus 1 all over what? 1.4. All right. So we are going to make P1 the subject. For us to do that, we are going to multiply. Just permit me to write 0.4 here. 1.4 minus 1 is what? 0.4. All right. So this is nothing but 0.4. All right. So now, for us to get P1, we are going to multiply the power of both sides by what? The inverse of what we have here. That is 1.4 all over 0.4. So if we do that, we are going to have 683 all over 333.55 all to the power of 1.4 all over 0.4 will be equals to 18 all over P1 to the power of 0.4 all over 1.4 multiplied by 1.4 all over 0.4. So if you look at this, this will cancel this, this will cancel this, right? Then we can therefore make our P1 the subject here now. So P1 will be equals to what? P1 will be equals to, if you cross multiply, P1 multiplied by this, this will come back here. So P1 will be equals to 18 divided by 683 to the all over 333.55 all to the power of what? 1.4 all over 1.4 all over 0.4, correct. Now if you divide this 18 divided by what we have here, you are going to have 1.465. so P1 is equals to 1.465 bar. All right, so now the next thing we are going to do is we are going to move to process 2 and what? And 3. So let's go to process 2 to 3. All right, now from process 2 to 3, you are going to recall that our process 2 to 3 is nothing but what? Our isothermal process. And you are going to recall carefully that from our isothermal process, we can apply our what? General gas equation. So which is nothing but what? P2 V2 all over T2 will be equals to P3 V3 all over what? T3. So this will be equals to Now, you are going to recall carefully that from state 2 to 3, that T2 is equals to what? T3. So, if T2 is equals to T3, definitely T2 will cancel out T3. So, we will therefore have P2 V2 to be equals to P3 V3. All right. So, if we make P3 the subject of formula here, our P3 will be equals to P2 into V2 all over V3. All right. So now let's substitute the parameters there. It means that our P3 will be equals to P2. What is P2? P2 is what? 18 into V2 over V3. V2, don't forget, we have V3 over V2 here, and there we have V2 over V3. So V2 over V3 is just the inverse of what is here. So it means here we are going to have 1 all over 1.5. So if you multiply this and divide it by 1.5, you are going to have nothing but 12 bar. So our answer here is 12 bar. All right. So now the next thing we are going to move to, process 3 to 4. Process 3 to 4. All right. So now for us to do this, you are going to recall carefully that our process 3 to 4 is nothing but what? It's nothing but adiabatic process. So, and for adiabatic process, you are going to recall that here we have P3 V3 gamma is equals to P4 V4 gamma. So we want to make P4 the subject here. P4 will be equals to what? P3 into V3 all over V4 all to the power of gamma. So if you substitute the parameter now, what is our P3? P3 is nothing but what? 12 into what is V3 over V4. Now you are going to recall carefully that V1 all over V2, V1 all over V2 is V1 all over V2 is equals to V4 all over what? V3. You are going to recall carefully that V1 all over V2 is equals to V4 all over what? V2. So everything will be equals to 6, right? So now, if you look at this, V1 all over V2 equals to V4 all over V3, not V2, V3. All right. So now, V3 over V4 is just the inverse of what is here, right? So now, we are going to have this to be equals to 1 all over 6. 1 all over 6 all to the power of our gamma here is nothing but what? 1.4. All right. So now, if you do this, it means that our P4 will be equals to P4 will be equals to, if you press 12 into 1 over 6 all to the power of 1.4, I'm going to have what? 0.976. 0.976 bar. So we are done with question number 1. Said we should find the temperature and pressure at all silent points. And you will agree with me that we have our P1, we have our P2. Our P1 is this, our P2 is given from the question to be 18 bar, and our P3 is nothing but what? 12 bar. Our P4 is nothing but 0.976, and our T1 and T2, T3 and T4 already have everything. So we are done with the solution of question number 1. So just for the purpose of exam purpose, when you are done, like, you can just list them: T1, T2, T3, T4, P1, P2, P3, T4, and you list all their answers. Is that clear? All right. So now we are done. So we are going to move to question number 2. It says that we should find the what? You find the change in entropy during the isothermal expansion process. The change in entropy. All right. All right. Do you still recall the formula for change in entropy? Change in entropy is denoted by change in S, like this. Is nothing but what? It's nothing but MR ln of what? Ln of V3 all over what? V2. Because we are told that change in entropy during the isothermal expansion process, and this is where we have our isothermal expansion process. It's going to be mr ln of V3 all over what? V2. All right, so you are going to recall from ideal gas that PV, you are going to recall from ideal gas that PV is equals to what? Is equals to mRT, right? So now if you make your mr the subject here, mr will be equals to PV all over what? T. Now, but don't forget, this PVT is going to be, is it going to be P2 V2 over T2 or P3 V3 over T3? Definitely it must be what? It must be at the beginning of the what? Isothermal expansion process. So which is going to be what? P2 V2 over T2. So we can just put P2 V2 all over T2. So now we are going to replace everything that we have here. Is going to be equals to P2 V2 all over T2 ln of what? Ln of V3 all over V2. All right. So if you substitute all the values, everything will be equals to, what is P2? P2 is equals to what? P2 is equals to 18 multiplied by V2. What is V2? V2 is what? 0.18. 0.18 all over T2. What is T2? T2 is nothing but what? T2 is nothing but 683 ln of V3 all over V2. But don't, we already have V3 over V2 here, which is what? 1.5. So this is going to be 1.5. So you close your bracket. So if you press all of this stuff in your calculator, your answer is nothing but what? 0.192. Is that clear? But what will be the unit? Can you still recall the unit? It's going to be what? Kilojoule per what? Per Kelvin. All right. 0.192. But I don't think that this place is going to contain it. But I don't want to clean this yet. So let me just manage it. 0.192 kilojoule per Kelvin. All right. I don't know if you can see that clearly. All right. 0.192 kilojoule per what? Per Kelvin. So we are done with question number 1 and we are done with question number 2. So now we are heading to question number 3, question number 4, and question number 5. Stay tuned. We need to clean this part. On question number 3, so we are asked to find the Carnot cycle efficiency. All right, so how do we do that? So we said that our Carnot cycle efficiency is denoted by this. So it's going to be equals to T2 minus T1 all over what? T2. So let's substitute. I clean up the board, but I can still recall some of the value. Our T2 is given to us from the question, and we said we convert it to Kelvin, which is what? 683. And our T1 is nothing but what? 333.55 all over what? 683. All right. So now if you press that and you convert, any answer that you get, multiply that by what? By 100. Exactly. So your answer is going to be what? 51.16%. All right. 51.16%. All right. So we are done with that question as well. Now the next question here says we should find our what? Our mean effective pressure of the cycle. Mean effective pressure. So we want to find the mean effective pressure of the cycle. We don't talk about this in our introduction class because this mean effective pressure, we will start talking about it when we go into what? Auto cycle. But let's just apply it under this question. All right. So I said V4. So mean effective pressure is denoted by PM, which is equals to what? The work done per cycle is equals to work done per cycle all over what? All over stroke volume. All right, so that is the formula. And you can see that stroke volume is just the difference between V4 and what? And V2. Exactly, V4 and V2. So, and our work done. Let's start with work done first. Then we are going to come to our stroke volume. All right, work done. When we say work done is equals to what? Is equals to quantity of heat supply minus what? Quantity of heat rejected. That is QS minus what? Minus QR. All right. But what is the formula for our QS? Our QS is equals to what? Is equals to it is supplied between what? 2 and what? State 2 and state 3. So it's going to be what? Either T2 or T3, anything you want, anyone you want to write here, because they are the same value, into S3 minus what? Minus S2. All right. So if you calculate this value, let's substitute into this value. What do we have? We get our QS. Our QS will be equals to T2. What is T2? For our T2 is what? 683. 683 into, now, S3 minus S2. S3 minus S2 is what? Change in entropy. Change in entropy during the what? Isothermal expansion process. Take note of that. So, and we've already gotten that. And we said our change in entropy during the isothermal expansion process is nothing but what? 0.192. All right. So, here we are going to have 0.192. So, if you multiply this, if you multiply 683 by 0.192, you are going to get your quantity of heat supply to be what? 131.11 kilojoule. 131.11 kilojoule. All right. Kilojoule. All right. So now let's go for our heat rejected, QR. All right, QR. The formula for QR is similar to what we have there for our heat supply, but it is being rejected as state what? 1 and what? And 4. So now our formula now, which is going to be either T1 or T4, but let's use T1. So it's going to be T1 into what? Into S4 minus S1. S4 minus S1. So what is our T1? Our T1 is nothing but what? 333.55. 333.55 into, all right, so you are going to note this, that the quantity of heat supply during the isothermal expansion process is equals to the quantity of heat rejected. Is that clear? So this place too, we are going to have this as 0.192. All right, so now our QR now will be equals to, if you press this value, you are going to get nothing but what? 63.97. 63.97 kilojoule. All right. So now the next thing we want to look for now is our what? Is our stroke volume. So we said stroke volume is equals to what? V4 minus what? Minus V2. All right. Now, we are going to perform some little analysis here for us to get our stroke volume. All right. You are going to recall that we already have our isentropic compression. That is V1 all over V2 is equals to what? 6. And then we have our isothermal expansion. That is the ratio, that is V3 all over V2 to be equals to 1.5. All right. Now, you are going to note something here, that we said something the other time too. We said that our V1 all over V2. We said our V1 all over V2 is the same thing as what? V4 all over V3. So V1 all over V2 is equals to what? V4 all over V3. All right. And we said everything now will be equals to what? 6, right? All right. Now, if you make V4 the subject here, V4 will be equals to 6 multiplied by V3. So V4 will be equals to 6 into what? V3. All right. So again, if you make V3 the subject of formula here, you are going to have your V3 to be equals to 1.5 V2. All right. So definitely now we can substitute V3. That is, we can replace this V3 here with 1.5 V2. So yeah, it means that our V4 now, our V4 will be equals to 6 into 1.5 V2. All right. So now let's substitute that here. It means that our stroke volume now, our stroke volume will be equals to 6 into 1.5 V2 minus our V2. All right. So now, if you press 6 multiplied by 1.5, it's nothing but what? 9. 9 V2 minus V2 is nothing but what? 8 V2. So it shows that our stroke volume, Vs, is equals to 8 V2. But you are going to recall that our V2 from the question is given to us as what? 0.18. So let's substitute that here. We are going to have this as 8 into 0.18. So if you multiply this, you are going to get your stroke volume to be equals to 1.44 meter cube. All right. Now we can now look for the value of mean effective pressure now. So mean effective pressure, PM, which equals to, we said, is equals to work done over what? Stroke volume. But our work done is equals to what? QS minus QR. What is our QS? Our QS, what is the value? The value is 131.11 minus our QR. What is QR? QR is equals to 63.97. All over what? All over stroke volume. Our stroke volume is what? 1.44. But don't forget, the two value of this QR, quantity of each supply and quantity of each detected, it is in what? Kilojoule. You understand? So now we are going to multiply this by, we can factor out kilo, and kilo is nothing but what? 10 to the power of 3, right? So now if you press this value in your calculator and you divide by 1.44, you are going to get nothing but what? Nothing but 0.466 bar. Please, the unit for mean effective pressure 2 is in what? Bar. So now this is going to be equals to what? It's going to be equals to 0.466. All right. So we have gotten our mean effective pressure. So onto the last question now. Onto the last question, and we are done. All right. The last question says that the theoretical power, so they want us to find the theoretical power, comma, there's supposed to be a comma here, if there are 210 working cycle per minute. All right, here they want us to find the power of the what? Of the Carnot engine. So we want to find the power of the Carnot engine, P. So the power of the Carnot engine will be equals to the work done. The work done by the Carnot engine multiplied by what? Multiplied by the working cycle per what? Per minute. So it's going to be work done, and our work done is nothing but what? Our work done is nothing but QS minus QR, right? So this is going to be QS minus QR multiplied by the working cycle per minute, and the working cycle per minute is what? 210. So it's going to be 210. Don't forget it's in per minute, we divide by 60. All right. So now let's substitute for Q. So we are going to say P is equals to QS. What is QS? QS is nothing but what? 131.11 minus QR. That is 63.97. Then we are going to multiply this by 210 all over 60. So if you press all of this value and you divide by 60, your answer is going to be what? 234.9 kilowatts. 234.9 kilowatts. All right. So I believe we have simplified this question to your taste. Is that clear? So I believe everything is clearly explained. So you can let us know that in the comment section. And thank you. Peace and love.